Hi, everyone, and welcome to the AWS Nordics office hours. We are back with a new season. My name is Gunnar Grosch. I am a developer advocate here at AWS, based in Sweden. And this is our weekly show coming out of the Nordics, where I bring on AWS experts to talk about specific topics. And you, our viewers, are able to then ask your questions, and hopefully by the end of the hour, you've learned something new about that topic or basically any AWS topic. So if you have any questions, just post them in the chat and we'll do our best to answer. And if you have any suggestions on upcoming topics, do post those as well. And this week, I am happy to be joined by my friend Nicolas Moutschen, Serverless Specialist Solutions Architect at AWS. Welcome to the show, Nicolas.
Well, thank you, Gunnar, for having me again. I think it's been a while, but really glad to be kind of the first for this new year.
Yeah, I think it was almost a year since the last time you were on.
Yeah, I think so.
So happy to have you back.
Yeah.
Do tell people.
We were talking about observability.
Yeah, exactly. Do tell people a bit about what you do at AWS.
Yeah, sure. So as you said, I'm a specialist solution architect for serverless technologies. So as solution architect, our role is to help customers when it comes to kind of discussing the topics at depth and so on, the AWS services to help you build solutions on top of AWS. And in my case, being a serverless specialist, I specialize, when we need to go deep on our serverless services, so AWS Lambda, Amazon API Gateway, Event Bridge, step functions, and a few others, then, I will come and intervene to kind of where we really need to go deep into the details of how these services work and how you can build complete serverless architectures.
And this week, we have a topic that I know you, Nicolas, are very excited about. We are going to talk about how to use Rust on AWS. And I think there's a lot to cover there. So we're going to start from the beginning. First off, want to say hi to everyone in the chat already posting messages. Keep your questions coming throughout the hour. So, Nicolas, first, tell us a bit about Rust, what it is and how we're using it.
Yeah, sure. And this will be also the opportunity for me to kind of scope away, not just talk about serverless, but talk about like Rust on AWS in general. So both the new SDK we have, to running it in containers, on EC2 instances, and so on. So Rust is a programming language that's still fairly new. I think, V1 was like in 2015, something like this. But it's been a very interesting language in terms of what it offers, right? It's a high performance language. It's fairly comparable to like C or C++ in terms of performance. But if you've ever done C or C++, you know how error prone it can be. You can have a lot of errors going on and so on. Rust promises to bring you more safety to that, right? Offer a lot of safety in terms of memory usage and so on, so that you can write application, like using a higher level language than C or C++, but get the performance that you would get in these languages.
So how long has Rust been a language that people use? When was it created?
Yeah, like when exactly it was created. Unfortunately, I don't remember exactly because it's been a while, right? I think it was a child project of Mozilla because they had lots of memory safety bugs that they wanted to eliminate. I think V1 came in 2015. So that's been, like 7 years that it's a language being used right now. I mean, still V1, but like V1.58, I think today. And one thing that's really interesting is how quickly it became popular. So according to the Stack Overflow developer survey, last year, Rust was for the 6th year in a row the most loved language. So there's definitely something interesting there. And I mean, for me, the reason why I'm quite interested in this language, right, is like exactly for that, right? Getting this nice performance, this nice little way of building things safely on top of that, which really fit into my mindset. I mean, I want something safe. I want something that's going to just work and so on, which is why I like serverless. And Rust is kind of offering that as a programming language. So I found it quite interesting there.
Yeah, if you ever watched this show before, you know that we want to do technical deep dives, and actually show things, how you actually use them. And we're definitely going to do that. Nicolas is going to show us examples of how to use Rust on AWS. So don't worry. So yeah, Nicolas, then tell us a bit about how we're using Rust at AWS today.
Yeah, sure. I mean, there's a few different projects internally that are heavily using Rust, right? So there's a few blog posts actually where we kind of go in depth into why we like Rust, what we do with Rust, and so on. And some of the reasons, right, that I listed kind of come into play. Let me just zoom it a bit for everyone here. But we have we've been contributing actually to a lot of the kind of open source community and so on. But if you think about what we have internally, you might have heard, for example, of Firecracker. I think it's a really interesting project. This is the technology that we use under the hood for Lambda and Fargate to isolate tenants. So when you are running your code on the Lambda function, when you're running a Fargate container and so on, we need to isolate the compute resources from different people, different functions and containers and so on, right? And so we use Firecracker to basically bring micro VMs, which allows us to bring VMs very quickly with a very low resource usage, and then tear them down when they are no longer needed really quick. And so this is built in Rust, right? For these reasons, because it's a security critical system, so we need safety, we need a language that's safe, we need something that's going to be as fast as possible, because the longer it takes to spin up these micro VMs means that when you have a cold start on your Lambda function, for example, and this is going to take longer and so on. So this helps a lot with these kind of optimizations.
And Firecracker today isn't something that's only being used at AWS, right?
Yeah. Yeah, no, there is... It's actually, I remember, I was at Serverless Day Paris last year, and there was one company explaining how they use, they made their own serverless offering, and they use Firecracker under the hood to actually provide that virtualization technology. So it's quite interesting. And yeah, all the companies are using that. It's completely open source, so it's free for you if you want to build this kind of capabilities to spin up micro VMs quickly and so on. Then you could look at Firecracker.
And you mentioned performance a couple of times now. In terms of performance or numbers, then how performant is Rust?
So this is the thing where I'm going to take my solution architect hat and start with it depends, because of course you can optimize things differently and you end up with languages that are faster than others. But one thing that's interesting, when we talk about performance, there was this paper released a while ago that talks about energy, time, and memory efficiency of different programming languages. And it's using standard algorithm and so on to kind of measure and baseline the performance across all these languages. And let me zoom in on the table we have here, right? And you can see that Rust on energy and time performance is, on the same level as C almost, right? There's a bit of overhead here, like 3 or 4% overhead compared to C. Memory is a bit lower, right? But I mean, here we still have a very efficient language in terms of time, and often because we don't have that much overhead and so on, the thing that's nice is that when you have something that's time performant, that can also help you be more energy efficient as well. So if you're thinking from a perspective of sustainability point of view, right, minimizing the usage of resources, having something that use less resources overall for just running compared to other languages is also quite interesting.
And then, so the other thing you mentioned was around security, and how can a specific language be more secure than another language when it runs in an environment like AWS Lambda?
Yeah, so that all boils down to really the design philosophy of Rust. So Rust is designed for safety in mind. And the first thing that it offers is memory safety. So, for example, when you have a multi-threaded application, right, you have concurrency and so on, you always have the possibility of some bugs emerging where you write or free some memory space before you read it, for example, and then you have inconsistency on the state. This is not something that Rust allows by design. You will have concepts like the borrow checker that ensure that, if you want to read the same address in memory a lot of time in parallel, that's going to be fine. but no two piece of code can have write access at the same time to the same piece of, to the same part of memory. That's one of the example of safety. It doesn't have null pointers, which also eliminate a lot of bugs and so on. So, and if I remember, there was a survey from Microsoft saying that 70% of the security issues we find, in code come from memory management issues. So just by design already, we have all these that are removed from the language itself. I mean, you can always do things that are unsafe, right? As escape hatches if you really know what you're doing. But the language is going to make sure you are, if you use safe Rust, you're going to be in this environment where you basically can't do these kind of errors yourself.
So when we talked before this session, I think we both talked about that we might get some very specific questions, which is fun. So I think we have the first one already. So let's bring that up. This is from Edelman. I have an existing server written in Rust that I want to run in Lambda. Is the right approach to initialize the resource in my bootstrap process and reverse proxy incoming request from within the Lambda runtime?
So there's actually a few options that you have here. There's, one, you can just do that. You bring, if you're using, for example, something like Rocket, which is a popular Rust library for bringing APIs, for example, you can just run that. And there is something called the AWS Lambda Adapter, which is actually written in Rust by a colleague of mine. And so the AWS Lambda Adapter will basically take requests coming from API Gateway or an application load balancer from AWS, and then call your HTTP server running on a Lambda function. So that's going to be the easiest way to do that. But then if you want to get a bit closer to an actual Lambda environment, then you can start decomposing your code. And once again, based on the framework you use, this is going to be more or less easy. So I've seen an example of people using that with Axum, for example, or with Poem, that would use that to have the same kind of starting. If your application is written with Poem or Axum, which are other libraries in Rust for creating APIs, it's going to be a bit easier because we're actually working on trying to make these things easier as well for the Lambda Rust runtime.
So we have a follow-up then from Edelman. Unfortunately, it's wrapped in additional functionality and the server service is hidden.
Yeah. Then the easiest one was probably to be using the Lambda adapter so that you can just bring, because the thing that's nice with Rust, it doesn't have garbage collection and so on. There's not runtime like you have with other languages. So the cold start performance is actually very low. Even if you're bringing a web server, usually the cold start performance is still quite acceptable. So that could be a really good way to start, right? And then you can start decomposing if you want later, if you want to really go the Lambda native route, right? But to get started, you can just use the Lambda adapter and bring your own existing application on Lambda.
Cool. I think we can put a link to the Lambda adapter in the chat as well.
Yeah.
Here we go. All right. So if you just join us, this is the AWS Nordics office hours with me, Gunnar. I'm joined by Nicolas today, and we're talking about using Rust on AWS. I see some familiar names in the chat, so keep your messages coming. So we talked a bit about what Rust is, how we're using it at AWS, and also a few things around performance and security. But we're almost 15 minutes into the show. I want to see some code, Nicolas. Can we perhaps look at an example of creating something with Rust?
Okay. So let's start with some Hello World, right? Just so we're all, something a bit more advanced than Hello World. You can just do Hello World very quickly here. First thing I want to show you.
Zoom levels on VS Code.
Yeah, exactly. So here, we have our VS Code. Zoom a bit more, you said?
Yes, I think so.
Yeah, there we go. Maybe one less like this. I think that's...
Yeah, that works. Great.
Yeah. Okay, so first thing I have is this cargo.toml file. This is just a way to define my crate. A crate would be, a project, a library, and so on in other languages. And so I just have the name, Hello World, version 0.1, edition of Rust 2021. That's just adding some extra features. And I define my dependencies here. So if you come from C, for example, and you know how hard it is in C or C++ to do dependency management, well, here we have everything built in, like you would have, with your package.json if you come from the Node world, for example. Now let's look at our function. So remember, Rust is a compiled language. So we need the kind of entry point, and that's the main function like you would have in C or Go. So if you're already using this language, that will be familiar. Fn is the way to define a function. And then use here at the top is because I'm going to use a create name run, so the run library, which will help me generate random numbers. What we'll have here is a function, a small program where I will generate a random number between 1 and 6, like rolling a dice, for example. So I'm creating a random number generator, and then I'm passing it to my roll d6 function. And that will give me a number between 1 and 6, and then I can just do println to display it here, right? And then my function here, roll d6, takes a random number generator, and we start to see a few things that are different from what you might be used to. The first one here is this mut keyword. So mut is for mutable, because a random number generator, the way it works is that you have an internal state, and every time you ask a new number, it will update the state internally. So this needs to be mutable because I will update the state every time. And that's very important for the memory safety point of view of Rust, right? If something is mutable, I can't have two things that can mutate the same value at the same time. So now I'm going to have additional safeguards thanks to that. And then I pass with the ampersand, to simplify, I'm going to say reference to it. If you are a bit more expert in Rust, you might know that I'm not exactly correct. And then I'm just, having my number here. And then I just use this command, cargo run, P, because I'm using multiple package here. So I'm just specifying my hello world crate. And then here I get my new number. Cargo run will compile and then run your program. And it uses incremental compilation. So if I modify my code, it won't recompile all the libraries that I depend on. It will just modify my code. Right. So if instead of doing from 1 to 6, I want to do from 1 to 10, I just do this change. And now it's going to build again and then get me a new number. But the next time I do that, I don't need to recompile, so it's quicker. So that's Rust in a nutshell, right? At a very high level, we have our function here where we pass something, return i32, so integer in 32 bits, and we have our value there. So let's look now at how, because right now, we said Rust on AWS, right? So right now we don't have anything related to AWS. So let's look at using the new Rust SDK. So now we have, an official SDK for interacting with AWS resources in Rust. This was released in developer preview at reInvent, right? Before it was in alpha and so on, but now in developer preview, it's still, if you are really building some hypersensitive production environment and so on, right? Be careful when you're using this, but it's already much more stable than when it was in alpha.
Does developer preview mean that there can be breaking changes to the SDK?
There could be, and if I remember, there's been a few small ones, right? And the way we do, actually, the Rust community is usually pretty good at semantic versioning. Right, so we are at the version 0.5 of the 0.6 of the SDK right now, and 0.6 has breaking change compared to 0.5 and so on, right? But as you can see from the way you specify dependencies, here I'm still on 0.4. This means that if there is a 0.4.7, for example, there should not be any breaking change, and my code will automatically update, which will be helpful if there's security updates, for example, for that version. And you can see here I'm using something called Tokyo, which is stable on version 1. So I can just say version 1, right? Because no matter what updates there are, I know it will be, there won't be any breaking change. People are making Rust libraries actually pretty good at that, which is really nice. So I'm going to have a small program here that will basically list my Lambda functions. As a serverless specialist, I have a lot of Lambda functions in my account. And so I'm just importing the client, arrow type, So that's going to be quite helpful in terms of how we do error management. And runtime model, I'm going to use that to list like the Lambda function runtimes, right? So Python 3.9 or provided AL2 and so on. So first thing we change here is that now we're going to do an asynchronous function here, because the AWS SDK is asynchronous. So that's why I'm using Tokyo. Tokyo provides an asynchronous runtime that will handle all these things for us, like handling the await and all these things and so on our behalf. Loading my config from the environment and initializing a new client based on that config. So that will retrieve the credentials and so on from my machine for this. And then I can make the API call here. So the way you do that, if you're used to other AWS SDK, might be slightly different. We use quite a lot of builder patterns in Rust. And so here I say, like, from my client, this is going to be a list function calls. And then I can add arguments on top of the default one. So here, for example, I want to limit to 50 functions. And then send to actually make the call, and then await. And then you see this little question mark here. That's another way another thing I like from a safety perspective in Rust is that how you do error handling. There's no exception catching or something like this. The way you do that is through this result thing here. A result is an enum that could have two values, either an OK or an error. And so OK is the first one. So OK, empty parenthesis means just no value. Or if there's an error, I have an error type that will contain all the information about my error. And when I do this question mark, it's a short circuit to say, if this is an error, send it back one level higher to the function, that because my function is taking a result as well. So send the error one level higher. I only want the OK value here. And by the way, you can see I have this list function output and so on. I'm using an extension from VS Code called Rust Analyzer. It's really convenient because it gives you all this type hinting and so on. You could see when I'm like passing my cursor around, you see lots of doc. That's thanks to that. It's really helpful when you're coding things. Then now I'm going to iterate over all my functions. So in the response, I have this function property that contains an option. An option is another type of enum that either contains some value or none at all, right? So that's a way to not have null pointers, for example. I don't need to check for null pointers. If I want to get the value inside it, it has to be something. If it's none, right, I'm going to have an error here. And so that's what I do with this match. Either there is some list of functions, and so I'm taking those, and then I'm iterating over them and printing them. Or there is none, and then I can just say, like, hey, no functions were found, right? So that's how, like, a few more advanced features here that you have in Rust, and then using the SDK. And so when I'm running my hello SDK command, it has to compile quickly. And here, I listed 50 Lambda functions that I have running in my account.
Yeah, that's fairly easy.
Yeah. I mean, the thing there's something that, will appear like really strange, like, why are you doing those a string, to string, and so on?
Yeah.
And that's where, I mean, the benefit of a strongly typed language and things like Rust Analyzer, for example, there we go. Immediately I got an error, and it's telling me, hey, this is the wrong type of thing. I'm expecting a string, but you gave me an str, which is not exactly the same thing. And so I can just do toString here to make sure, that this is working as expected. So the error are actually quite helpful, which is nice if you're getting started with Rust.
So now you're running this locally only. Then if you were to deploy this to AWS Lambda then and run it there, what do you have to do?
So now we get into the other part, which is, so once again, Rust is a compiled language. And that's going to be, if you know about Lambda, you know that, for example, if you use Python, you can just put a Python script in there and so on. That's not going to work here. You need to provide a binary. And so the way to do that is that there is a runtime library that will take care of wrapping your logic into something that Lambda will be able to use. So we have this Lambda runtime crate here with this handler function, Lambda context, and once again, I have this error type, right? And I'm using here, run prelude to generate some random numbers. And I'm creating a request structure and a response structure, right? So that's going to be the request I get in my Lambda and the response I want. And these derived things here with deserialize and serialize, it's because since I'm going to send a JSON payload, I can deserialize my request from JSON into this struct. And same thing for my response. I can serialize my struct into a JSON payload. And the Lambda runtime will take care of that automatically for you. You just need to make sure that you have this derived, deserialize and serialize here, so that it will automatically implement the right functions for your struct, basically. So here, this is my main function again, where I also have this Tokyo main. This is again async, and I wrap with handler function. I write my function handler, and then I just run my runtime here. Then in my handler itself, so that's going to be my Lambda function proper. Then here I'm taking my event, and I'm using that. So what I do here is this function actually is that I ask how many dice do you want and what's the size of the dice, right? So people that know Dungeons and Dragons, I mean, I played a lot of Dungeons and Dragons and so on. So we have like 1d6, 1d20, because we have dice with 6 faces or 20 faces and so on. So here you can say like, okay, I want 3 dice with 20 faces, for example. And so it will take these values. So it will roll, it will iterate over the number of dice and then generate a random number, for the size of the dice, and then take the sum of that for that and send that as a response. All right, so that's how I'm going to write my Lambda function here.
All right. So talking about the SDK once again, I'm not sure if that's the right word, but how mature is the SDK compared to other SDKs that we have?
Yeah, I mean, if you compare it to the AWS SDK that's been around for years and so on, I think it's pretty close, but it's still in developer preview, right? So there's still some features that might be missing. Until recently, we didn't have SSO, single sign-on support, for example, but now this is supported. So there might be still some things around the edges that might be missing. But as far as I know, all the AWS services are supported today. So all the APIs that you have from all the services, I think they're all supported today. There might still be some bugs here and there. There might still be some gotchas, right? Because that's the point of the developer preview, right? So if you want to kind of dip your toes into that as you're learning Rust and as you're making proof of concept for using Rust with AWS and so on, and you find bugs, like let us know. Create issues on the GitHub repository so we know what's going on. But it's pretty close.
And you mentioned for certain production workloads that you perhaps shouldn't use it.
Yeah.
So what would you do then if you want to run Rust on AWS, but perhaps not use the SDK?
Yeah, I mean, because there's been historically another SDK that was made by people from the community, so not people from AWS, called Rusotto. I would actually, if you want to use something, if you want to use Rust and so on, I would recommend to still use the Rust SDK because it's going to be today, more feature complete and with less chances of bugs than the Rusotto. So if you are using Rusotto today, right, consider moving to the Rust SDK. But that said, if you are into some kind of mission critical system and you need the rubber stamp, this is generally available and so on, I would wait, right? That's the answer for that one. And then look at other languages and other SDK for now. But based on your timeline where you are right now in terms of using Rust and based on the criticality of your workloads, you might want to use the Rust SDK or not. Like, do your own assessment, basically.
Yeah, exactly. So everyone, if you just joined us, this is the AWS Nordics office hours. We are back with a new season. And for this first episode, I'm joined by Nicolas and he's showing us how to use Rust on AWS. So really jumping in the deep end of the pool straight away for this season. He's shown us a few examples of how you can get started using Rust. We also looked a bit at how to use the SDK for, in this example, fetching a list of AWS Lambda functions running in Nicolas' account. So besides AWS Lambda then and Rust, how would you go about using Rust for other platforms?
Okay, so let's move a bit, to another example I have. So because here, this were like hello world, fairly simple example and so on. If you want to go deeper, I built a more complex application. Actually, I started building it first for Lambda. I'm still a serverless specialist, right? So I had to start on the Lambda side, but this is going to be a bit more complex here. So if I show first the architecture diagram, where do I have it? Yeah, images diagram. So see, if I show first the architecture diagram of this solution here, you see I have 4 Lambda functions fronting an API gateway. So I provide an API this way, Dynamodb table, and then I have a Lambda function on the other side listening to Dynamodb streams. And so here I have a bit more logic to interact with things. And I've used something called the Hexagonal Architecture, right? So the idea of a Hexagonal Architecture is to decouple your business logic from these kind of connectors. So I have a connector here for the fact that it's running on Lambda behind an API gateway. I have a connector to connect to a Dynamodb table and so on, right? To isolate that so I can easily swap these things. And so if I start at a high level, right, I have, for example, a function to delete a product from my database. And so here I have the same thing as we had with Lambda, for example. And I've ported it to running in container as well. So here you can see I initialize a Dynamodb storage to get my values and so on. I set up tracing, and then I run my function delete product, for example. And so if I want to run that in a container instead, then this is what it would look like. So I'm using something called Rocket. I mentioned it earlier. This is a pretty popular library for building API in Rust. And the way you would do that here, and that's the benefit of this kind of adapters and ports combined with Rust being a compiled language, right? So I have this zero cost abstraction. So even if my architecture of code is a bit more complex because I isolate my things here, it actually ends up being still pretty fast. Because at compile time, we can optimize and strip down a lot of these layers of complexity. And so here I have a config structure that I will use to store my Dynamodb store. And then I have a bunch of functions defining all the points in my API. So for example, delete, / and then a certain ID, for example. And then I have this function here, asynchronous function, once again, to delete a product that will retrieve the state. So I can retrieve my store and the ID of the product I want to delete. And then I make my call the same way I would do in the Lambda function, and then I handle the result here. Here, the thing that's nice, right? I can just send a string back, or I can just send a JSON object. There's quite a few options with Rocket, which is quite nice. Here, I kept it simple. Same thing, if you go actually in the details, you see that the error handling is not exactly the same what I've done here. But this is how you would define, and then for each of my routes, I have another function, and Rocket will take care of handling, routing the traffic to the right API, to the right function for me.
Right. So then from this, you would create your container image that you could then use with, for instance, Fargate or ECS or EKS or something like that.
Yeah. Or EC2, like this way. This will be quite flexible, or as Eden mentioned earlier, I already have an application I want to return Lambda. We also have Lambda Adapter, right? So this you could run basically anywhere on any compute on AWS.
So can you show us one of the Lambda functions where you're interacting with Dynamodb? So to get a sense of what that looks like as well.
Okay, so let's go a bit deeper. So I showed, the entry point with the main and so on. Here I have my Lambda function logic, right? So delete product. I take a store as an input, take my request. So the store is going to be how I interact with Dynamodb. And then here, I have my domain function where I put my domain logic, where I pass the store and the ID to delete the product. The domain logic here is very simple because this is this is just like a simple API and so on, but this is where you would have some kind of business logic if you want to check things, like you can't delete a product if X conditions are met, for example. But here I just delete the product. And so now we get into my Dynamodb store implementation, where here, when I create a new one, I pass a Dynamodb client from the SDK and the table name. So I have something, that's abstracted away to handle all that for me whenever I do request. And so if I go into the delete, so that's get, that's delete, for example, here. So I take self and I pass the ID, and then I just do self client, delete item, pass my table name, pass the ID, send and await, and hopefully everything works fine.
And this is, I think, based on the architecture you showed, I think that's something that many that have built something using serverless on AWS is very familiar with. Basic CRUD application where you're able to do operations towards Dynamodb data store. And I think you mentioned that you or other SAs at AWS have created similar or equal applications using other languages. Isn't that right?
Yeah, that's correct. So if I go, let's go to the repository itself, and let me zoom a bit. There we go. So that's the repository, by the way, for this project. If you want to look at the container implementation, you can find it on the pull request. You'll have one saying, add Rocket implementation if you want to go compare the two. But then from Rust, other people, other solution architects at AWS have implemented it in other languages. So if you come from, for example, TypeScript, for example, and you want to see like, hey, what's the difference? We all use the same architecture pattern. So we all use, hexagonal architecture and so on. And we have different implementations. So Go, Groovy, GraalVM, so for Java, Kotlin, and TypeScript right now.
And
more coming.
Based on that, then, have you done any benchmarks comparing the different languages?
Yeah. So that's the nice thing, because we all implement the same API, right? So that means that we can take the test suite from one language and just run it on the other ones, for example. And I made an artillery script, and so you can see here, for example, so the memory setting is not always the same between languages, because sometimes, for example, if you do something on Java with the JVM, you need a bit more memory to get started, for example, to just run the JVM. But you can see the performance for the API part. So you see here, the second line is the call starts, and the first line is the warm starts for Lambda function. And you can see here, this is with 128 megabytes of memory. I'm at 5 milliseconds at P50, 13 at P90, for example. Call starts is 122, 140. It's because we initialize the SDK, we need to do the first connection, DNS resolution, and so on. I actually spent a bit of time diving deep into why was it so high. And it's DNS resolution, establishing the connection, and so on, that take time. But then if we go, for example, to Go, a lot of people compare Go to Rust, for example. And we can see here how the performance compare, right? So in terms of P50, P90, I'm not sure if Go use 128 megabytes of RAM or 256, because that could be the difference. 5 milliseconds is kind of the ceiling because of Dynamodb calls. But then you can see on the call start, we're already at 400 millisecond call start, because we have a bit more things to initialize on the Go side.
That's interesting. And then can you also open up either Python or JavaScript?
TypeScript would be good. I want to show Java with GraalVM because this one's going to, like, it's a bit out of scope for the Rust one, but if you use Java, don't necessarily change your own language for this, because you can see this is with 256 megabytes of memory, but you see we get a fairly respectable 5 milliseconds here as well. And now when we go to TypeScript, by comparison, yes, this is quite small here. Unfortunately, the more I zoom, like, the image stays the same. Let's see if I can zoom. Yeah, there we go. Yeah, here you can see 6 and 15 at P90 with 700 milliseconds for the cold start.
That's interesting. I think we had 5 and 13. Was it at Rust?
For Rust, yeah. But this is also with more memory, by the way.
Yeah.
The thing is that we all were different people implementing that, and we didn't agree on how much memory we should give to our Lambda function. And for me, on Rust, I was using something like 30 megabytes. I was like, why would I do more? I'm very happy with this performance. The one on Rust is there.
That's very cool. All right, folks. So Nicolas is showing us how to use Rust on AWS on this episode of the Nordics Office Hours. So we've looked at a few examples of how to use Rust, how to get started, and how to use the SDK to interact with other services on AWS as well. So next then, Nicolas, if one of the viewers, if they want to get started using Rust, what would be a good way to get started if you're unfamiliar with it totally?
So I have to commend the Rust community in general, because they put some really good resources out there. So if you go on Learn here on the Rustlang website, there's these 3 things here: the Rust book, the Rustling course, and Rust by example. These are already fantastic resources to get started, honestly. So this actually, so when I started learning Rust myself, I used these 3. I mean, these are free resources. Even if it's a book, it's an online book. And I used a bit, each of them based on where I was in my learning and so on, right? Because some will explain to you the concepts of Rust. Some will, be like hands-on coding that you'll do and so on. Some will also be a bit more hands-on, showing examples for you to learn from. And so based on what's best for you at that time, and you can pick one or the other. In terms of what I would recommend you to do, like, don't start by creating a library just yet, probably. Maybe start with creating some CLI tools to get used to that and so on, because that's probably going to be the easiest for you to get a grip on. Then doing things like an application that are running on Lambda or on containers would be a next second step and so on, right? To get you used to that. Libraries, the thing I found that when you're learning a new language, creating a library can be tough sometimes, because if you want to create a nice API for others to consume, you might need to learn a bit more about how the internal language works for that. And that might be a bit trickier at first, right? But these 3 resources, they are free. That's what I used to learn myself, and that worked pretty well for that. And highly recommend, as you're learning as well, use the Rust Analyzer extension for whatever IDE you're using, because the first experience you'll have with Rust might be frustrating because of this memory safety and so on. You might be using to do things in a certain way in a lot of language, and Rust is going to work a bit differently for safety reasons. And so that means you will get errors at the beginning. That's normal. Everyone's went there. But the Rust Analyzer is going to be quite helpful at giving you feedback, giving you a good overview of what's going on and so on. And that will save you a lot of time and a lot of headaches for troubleshooting these issues as you're learning the language.
I think that's a great tip. And I'm not sure if we probably don't have any numbers to share, but how do you see adoption of Rust on AWS today? Do you see customers actually using it, or is it more the geeky kind like you, Nicolas, who are using Rust today?
Yeah. So, It's interesting where it is today, because I think it's still early days in terms of the Rust adoption and so on. What I see a lot is people interested. So I mean, ever since I started to be a bit more advocating a bit more about Rust, started to have a lot of people saying, okay, I'm building a POC for Rust on AWS, or we put our first microservice in production and so on. I think this is the state where a lot of people are right now. Now there are companies that are running, large-scale application with Rust, on AWS in production today, right? So there's definitely we are running, large-scale application using Rust ourselves, with things like Firecracker, for example. So there's definitely, in terms of maturity and so on, the possibility is there. I think it's just a matter of people are learning Rust still a lot right now. So that's kind of the state where we are, where everyone's kind of interested, wants to learn more about it and so on, and start, POC, start doing experimentation, start putting the first service in production with Rust and so on.
Right. So, Nicolas, do you have any more code examples to show us before we start wrapping up? I think code is always what we want to see and what the viewers want to see.
Yes. Yeah, I can go into some of the more interesting things in Rust that I didn't have the chance to mention earlier. For example, so when you create a struct in Rust, you can create an implementation. So that would be defining the functions for that struct and so on, right? So that you can do store dot something. So for example, here I have this new function to create a new Dynamodb store. But then you see this imp store for, imp something for this. This is the trait system in Rust. So in other languages, these would be called interfaces. And in Rust, we have these traits. And so here, for example, the benefit of doing that is that, let's say I want to swap my Dynamodb store for another type of, storage backend, for example. I can tell my function that will take a store, like I will take a dynamic store, or I'll take something that implements this storage, this trait, for example. So I have a trait for each, for getting all the items, for example, or the one we were looking at earlier for deleting. And there it is. And so this will be helpful. If I look at my function signature, you see here, so store delete is a trait. It's not a struct. It's not a concrete implementation. And here I'm just saying, I need something that's dynamic. That's the din prefix. That implements the store delete trait. So I know that I can do my delete call on this safely. I know that's going to have the delete call that I need, but I might not know. I might know only at compile time or at runtime what's going to be the actual implementation I'll have. So that's one way to do that. Thing that I wanted to show. And the trait system is widely used within Rust. So, for example, I have a struct that represents my product, right? It's a product model that I will use across the application and so on. And the AWS SDK doesn't give me, a definite struct. It gives me a hash map, so a key value store with a list of string and attribute value that's the time specific to Dynamodb internally. And so if I can this from trait, I can implement this from trait, which comes from the standard library, to do value-to-value conversion for me as a way, as a fairly standardized way. And all I have to do is implement this from function, and then this will take my product and transform it into something for Dynamodb. And I have the same in the other one, in the other direction, except it's a try from, because I could have an error. And so it will take a hash map and convert it into a product, for example. And so now if I go into, let's say, my get function, when I get my result from Dynamodb, I can do a try into instead. And that would be a typical Rust way of doing this kind of type conversion, for example. So here I can do a try into and convert it into an item, or on the other direction. So when I'm writing, so when I do put, with my put, there it is, I will do an into to convert my product into the data for my DynamoDB request, for example.
All right, that's interesting. So I want to share the link to the repo once again, so people can have a look at the example we showed. Let me just paste that. And then, Nicolas, so let's just repeat some of the benefits of Rust before we wrap up this session. Why would anyone use Rust on AWS?
So at a high level, going back to the Rust webpage, this is true, right? Performance, reliability, productivity. So we have high performance almost at the level of C. All these safety features, that I showed, like this result, to handle errors, the memory safety, so I can't write something that someone would read at the same time, and so on, and other patterns that I have for that, right? No null pointers. The productivity, like the errors, are super helpful, and then with tool like Rust Analyzer, this is even better on this. So that means you can write code fairly fast once you get to know Rust. It's going to be fast, and there's lots of errors, lots of potential bugs that, just thanks to the design of the language, might just don't be there, right?
And as you mentioned before, during reInvent in end of November, beginning of December, the AWS SDK for Rust was released in developer preview, so that's available now as well. So now is a very good time to start using Rust for that reason as well.
Yeah.
So, Nicolas, I want to thank you for joining us today, talking about AWS, or talking about Rust on AWS. Great to have you. Let's not wait a year until next time. If the viewers have any requests for topics where you want to see Nicolas talk about, please send those in the chat or connect on Twitter or LinkedIn. I know it's the same. Nicolas is available on Twitter. You can see his handle on screen right now.
Right here now.
There it is. All right. Yeah. So this was the first episode of AWS Nordics Office Hours for this season. Next week, I am joined by AWS data hero Anurag Kale, who's joining us to talk about some of the data releases we saw out of reInvent. So don't miss that session. There was a question. Let's bring that up. Yeah. So is the AWS SDK for Rust complete as other languages?
So yeah, once again, on the SDK for Rust, I think in terms of the services is going to be complete. Or for my experience, it's complete. I mean, it might still be missing a few things here and there. It's mainly going to be some of the features that you might have in other SDK might not be there. So mentioned earlier, until recently, we didn't have SSO support, single sign-on support. So if you were using AWS SSO, that would not work with the Rust SDK, but now that's implemented. And that's going to be small things like this, that might still be missing today. The last thing is, in some edge cases and so on, I mean, there's lots of tests and lots of people testing it. So we've been able to already eliminate quite a lot of bugs there. There might still be some bugs in some areas, right? So if you want to test it, if you want to experiment with it, please do. And if you find a bug, please let us know by opening a GitHub issue. The developers being behind the SDK for Rust are super responsive. So they'll be able to help you if you find a bug.
All right. So with that, Nicolas, we're going to end this session. Thanks once again. Thanks for everyone watching. It's great to be back again.
Yeah, thank you very much.
Thank you all. See you next week.